What's up everyone, welcome back. Patrick here, moving on to the next problem, still dealing with quadratic equations. So what we have to do is write a quadratic equation and factor it in standard form for each set of these roots over here. So this is a pretty cool question, a common question. This is kind of going backwards with what we're used to. So far what's been happening is we've been given quadratic equations, so something in this kind of format. Sometimes it's given in this format, sometimes we have to rearrange it to put it in that format. And then we solve for x over here. That would make this left side equal to 0. And there's different ways to solve for it, but we've been focusing on factoring. So we take this standard form quadratic, we factor it. So it ends up going in that kind of format. And then we solve by seeing when each of these factors equals 0, right? And this is going to happen when x is equal to m. This is going to happen when x is equal to n, like that. And then these over here, these are called the roots. So that's what we mean by roots. You may see different terminology used. So it could say, for each set of solutions, the roots, same thing. So basically, for part A, the solution to a certain quadratic equation is going to be x equals 4 and x equals 7. Right? That's what it means with the roots 4 and 7. It's at these points over here, and that's going to be the rest, the same for the rest. So like for part B, we're going to have x equals -3, x equals 5, etc., etc. Now, let's, before getting over here, let's do a quick, just example. So let's say we have like x squared minus x minus 6 is equal to 0. So what we would do is we would factor this. It would be x minus 3x plus 2 is equal to 0. And then we could tell x minus 3 is equal to 0. So one of the roots is 3. And over here, x plus 2 is equal to 0, so one of the roots is -2. So just a real example that we can use to solve these. So basically, we're going to be going backwards now. So let's start off with part A. We got x equals 4, and then x is equal to 7. So what we want to do is we want to go backwards. And so notice that if we started here, how would we get over here? Well, we would bring the 3 over. We would bring the -2 over. So same thing we're going to do over here. So we're going to bring this over. We're going to have x minus 4 equaling 0. And then we'll have x minus 7 equaling 0. And so those right there are the two factors for the quadratic. It's going to get a little bit more complex when we're going to start dealing with fractions, and we'll get there. But with these kind of integer roots, this is basically how it works. And so we went from here to here, right? Here to here. So same thing as going from here to here, here to here. And now we can basically combine those roots. And so the quadratic we end up having, quadratic equation we end up having is that right there. So that's the quadratic equation in factored form. Another thing I want to mention is that notice that here there's like an imaginary 1, but there could be any number over here. Okay, and then these roots would still stay the same. So going back to here, let's say we had like a -5 in front like that. Well, when we're solving this quadratic equation, we know -5, that factor can never equal 0. So we just ignore that, as we've done in previous videos, and then we still check when does x minus 3 equal 0, when does x plus 2 equal 0, right? So this number here could be anything. Could be -5, could be 10, could be 1,000, could be whatever in front here. So we could just put maybe like an A, right, to symbolize any general number. So anything can be over here as a heads up. So there's an infinite amount of quadratic equations that you can make with these two roots over here. But these brackets, these factors definitely have to be there, right? In order for those to be the roots or the solutions to this quadratic equation. The only thing that could change is whatever that a value is in front. You could just keep it simply as just a positive one. So your textbook, your teacher's probably just going to expect to put some kind of equation there, and you could just simply keep it as 1 and not even put anything there, but you do have the option to put a 3, a -3, or whatever other number in front here, and that's going to keep the same solutions. But I'm just going to keep it as 1. I'm going to keep it as 1 for all of these, but just wanted to mention that up front. So that's pretty much it. That's the solution to part A. Now, they said that they want it in factored form, which is what this is. But they also want it in standard form. So all you would do in that case is you would just expand this. And when you expand it, FOIL it out, you'd end up with x squared minus 11x plus 28 equaling 0 like that. Right? So those end up being the solutions for part A. So if you got a quadratic like this, quadratic equation like this, you would factor it into that, and then the solutions or the roots you'd end up getting is 4 and 7. Okay, so fairly simple process. Again, you're just going backwards. And so you could do that with the rest of these. So we can have, you could start off with writing the solutions, x equals -3, x equals 5. Well, we bring this over, it would end up being x plus 3 is equal to 0, x minus 5 is equal to 0. So we end up here. So those are the factors, pretty much. And so we end up with x plus 3, x minus 5 equaling 0. That's the factored form. And then if you want it in standard form, you would just expand this. So we would end up with x squared minus, you'd have -5x plus 3x, which would give us -2x, and then we'd have minus 15 equaling 0 like that. All right, so we end up with those sets of equations. And I just realized actually that I screwed these letters up. So notice that we have A, B, and then this here should be C. So let me actually just change these in the proper order, my bad. So we'll have C, D, E, F, G, and then H, like that. Right, so for part C, we have two roots, 0 and -11. Now what happens with 0, that's a unique one, well, it's just x equals 0. And then we got x equals -11. Here we can't do anything. We have to just leave it like that, but the -11 we could bring over. And what happens when x equals 0 is one of the roots? Well, that means one of the factors, if you remember, is just x. So what we would end up having is x times x plus 11 is equal to 0 right there. Right, so let me actually write that over here. We'll have x. You know what? And that's for this one. Let's put a number in front. Let's put like a 2. So we'll have 2. We don't have to. You keep it as 1 if you want. I'm just kind of switching it up. So that ends up being the factored form quadratic. And then if you want to expand that, you'd end up with 2x squared plus 22x is equal to 0. Okay, so these equations over here, they're both the same. And the solution to those equations, or the solutions, is going to be 0 and -11. And so moving on to the next one, which is part D, we got roots 3/4 and -6/7. So here's where it's going to get a little bit unique, nothing too crazy, but whenever you have these fractions here, it's going to require just a little bit of algebra. So what I want to do is actually just do a random one, and let's pretend that the factors we got was like, I don't know, 3x minus 1, and then let's say 2x plus 5. Actually, I think, yeah, we'd end up having that root over here. Let's do like 2x plus, I I don't know, 7, let's say. Okay, so let's pretend that we got a quadratic equation like this. So what would happen, we find out when does 3x minus 1 equal 0? When does 2x plus 7 equal 0? And so remember, there's a bit of algebra involved here. So we bring the negative 1 over, so we find out when does 3x equal positive 1? And then we divide both sides by 3, and we end up with x equaling 1 over 3. Or over here, when does 2x equal negative 7? This is going to happen when x is negative 7 over 2. So that's how we end up with roots that are fractions, right? They come from these factors that are not just like x plus 5 or x minus 2. There's an actual coefficient in front here. And so what's going to happen is eventually we're going to have to divide both sides by that coefficient, and that's how we end up with denominators, and that's how we end up with fractions as the roots. So going back to here, what you want to do is you want to take these and convert them to these kinds of factors. So let's go back to this example. How do we go from here all the way back to here? Or how do we go from here to here, let's say? How do we get rid of the fractions and then bring everything over to one side? So all you do, let's forget about these for now. Let's stick with this example that we just did. Let's say we got 1 over 3. All you do is you actually just cross multiply. So we go 3 times x, which gives us 3x, and then we go 1 times 1, which gives us 1, and then we could bring the 1 over, and we end up right there. So that's pretty much it. So let's do it with the negative 7 over 2. So if we got x equals negative 7 over 2, okay, we could put this over 1, cross multiply. So we'll have 2 times x, which is 2x, 1 times negative 7, which gives us negative 7. Bring the negative 7 over, and we end up right there. So that's how we can get those factors. That's pretty much the process whenever you have roots that are fractions, right? You just cross multiply in order to get rid of that denominator, and then you just bring everything over to one side, so to make sure that you got that 0 on the right side. Okay, and that's pretty much it. So if we take that same process and apply it over here, this x we could put over 1, this we could put over 1, so we go 4 times x, which is 4x, 1 times 3, which gives us 3, and then bring the 3 over, we end up with that, like that. And then over here, same thing, cross multiply, 7 times x is 7x, 1 times negative 6 gives us negative 6, bring this over, so we end up with that. And so for part D in particular, those end up being the factors. Okay, so let's split this off here. Sorry, I'm kind of going all over the place. Yeah, let's put the solutions over here. So for part D, we'll have 4x minus 3, 7x plus 6 equaling 0, like that. And if you want, you can check your answer. So you could forget about everything and then just take your factored form quadratic that you have and solve it. So if you just got this as an equation, well, we'd be finding when does 4x minus 3 equal 0, when does 7x plus 6 equal 0. Well, this is going to happen when 4x is equal to 3, or when x is 3 over 4. This is going to happen when 7x is negative 6, or when x is negative 6 over 7. And notice 3 over 4, negative 6 over 7, 3 over 4, negative 6 over 7, like that. And that's pretty much it. So that's how you work with these sort of roots that are fractions. It's just a little bit more algebra, but it's not too bad. And again, you could always make sure you could take these, pretend that they're actual equations you're solving, isolate for the x, and make sure that you have those original roots that you started with. Okay, so that ends up being the quadratic equation right there. That's in factored form though, so if we expand this, we would end up with, let's not skip too many steps here, so 7x times 4x would give us 28x squared. Then we'll have 24x minus 21x minus 18. These are like terms, so we end up with 28x squared plus 3x minus 18 equals 0. So that ends up being the corresponding quadratic equation in standard form. I'm just making sure that I expanded it all good. Yeah, looks all fine to me. Okay, so that's the process. So if you didn't catch that fully, it's good because we have just a bunch more that we're gonna do here. So we got e, 5 and negative 3 over 2. So we got x equals 5, we got x equals negative 3 over 2. Here, easy to isolate, bring the 5 over. Boom, x minus 5, that's one of the factors here. It's going to require a little bit more work. Cross multiply, 2 times x gives us 2x, 1 times negative 3 gives us negative 3. Bring the negative 3 over, and we end up with that. So that ends up being the other factor. Okay, so for part E, the factored form quadratic equation would be 2x plus 3 times x minus 5 is equal to 0. And again, if you want to check your solutions, it's a good point. It's a good time to do it at this point when it's factored. Find out when does this bracket equal 0, when does this bracket equal 0, and you would notice that you'd get both of those corresponding roots that you started with. Okay, and then if we expand this, we'd end up with 2x squared, negative 10x plus 3x, so that would give us negative 7x. Like that. Yeah. Right, so that's the factored form quadratic equation. This here is the standard form. Again, also, even with these sort of more complex factors, you could still put whatever number you want in front there. You could put like a 5, you could put a negative 2, whatever you want. It's just when you expand it, make sure that you expand that value to all of these values as well. Okay, so again, this whole time we've been doing this, even up here, this a value in front was 1, but just remember you could put anything there that you want. But I'm just going to keep it as 1. And then moving on to part F. So notice in part F here, we actually have one root, 7 over 3. And if you remember, when does it happen where you have a quadratic equation where you only end up having one root? It's going to happen when you're dealing with a perfect square trinomial. So for example, if we got something like x squared minus 10x plus 25 equals 0, this is a perfect square trinomial. It's going to factor into x minus 5 squared. And so there's only going to be one factor where it could equal 0, and that's going to happen at an x value 5. So that's how we end up with one factor. So if we have one solution, one root, right? Which is the same as just one factor. So the way that we end up with one root is we know that this is going to have to end up being a perfect square trinomial. So if we have x equals 7 over 3, again, to get the factor, cross multiply, bring the 7 over, like that. So we have one factor, but we don't just leave it like this, because this would be a linear equation. Remember, this has to be a quadratic equation, so we have to actually add a 2, like that. So let me split this up over here, put the solution. So for part F, The solution is actually 3x minus 7 squared is equal to 0, like that. Right? And from this, we're only getting that one solution, one root of 7 over 3. If we were to expand that, this would end up being what? 9x squared minus 42x plus 49? Like that. Right? This is a perfect square trinomial that factors into this, and this only gives us one root or one solution, which in this particular case is 7 over 3. Right? So just be on the lookout for these kinds of questions where they give you one root. It's going to be a perfect square trinomial. Another case to look out, these last two cases are actually this, is where you end up with plus or minus that same root. When is this going to happen? When you're dealing with a difference of squares. So for example, if we had like x squared minus 9 equals 0, well, this factors into x plus 3, x minus 3 equals 0. And so the solutions from both of these would be x equals negative 3, x equals positive 3. Or if you combine them, plus or minus 3. Right? So these kinds of solutions are coming from a difference of squares, like that. Okay, and you could rewrite this. So if we go here, plus or minus 4, we got x equals 4, x equals negative 4, like that. So we have x minus 4 equals 0. There's one factor. We got x plus 4 equals 0. There's another factor, like that. Right? And so we'll have part G. Let's put the solution up here. You know what? Let me put the solution here. Sorry, I'm kind of all over the place with this particular question. Running out of room. So that's the factored form. If we expand all this, we'd end up with x squared minus 16 equaling 0. Right? A difference of squares that factors into that. Both of those factors are going to give us roots or solutions of x equaling plus and minus 4. And then the other one is plus or minus 5 over 2. That's a difference of squares as well. It's just the factors are a little bit more complex. Split this off. 5 over 2, negative 5 over 2, like that. But same thing that we've done before. We just cross multiply. So here we'd have 2x equals 5. Bring this over. 2x minus 5 equals 0. Here we'll have 2x equals negative 5. Bring this over. It ends up being 2x plus 5 equals 0. So those right there are the two factors. So the factored form would be 2x minus 5, 2x plus 5 equals 0. That's the factored form quadratic equation. That's going to have these two solutions. And then if we expand this, we'd end up with 4x squared. Those middle terms are going to cancel out. Minus 25. Like that. So those end up being the solutions for part H. Okay, so that's how you work with these kinds of questions where they give you the roots and then you have to give the original quadratic equation. Sometimes they'll allow you to just stop at the factored form, but a lot of times they'll want the standard form. So then you just get the factored form, expand it, and then you put it in standard form. And also, always remember there's an infinite amount of these because you could put any number in front here. For all of these, I've just been keeping it as a 1. But you can technically put whatever number you want there. So sometimes they may even ask you to provide like two different quadratic equations. Well, all you have to do is change that number in front. Okay, the roots are still going to be the same, but that number in front changes the entire equation. All right, and that's pretty much it for this type of